Welcome to the Genius Factory. Enjoy the video.
You begin by confirming geometry integrity. This saves time later. Open your part or assembly, inspect for small gaps and flipped faces, and repair them now. Next, decide why you need the mesh accuracy or speed and pick tetrahedral versus surface accordingly. Once chosen, set a global element size around 0, 5 to 2, 0 units as a starting point. This gives a balance between resolution and computation time. Make sure to save a copy before meshing. Now you refine the mesh with controls that target problem areas. You add curvature and proximity controls to capture small radii and thin walls. This prevents excessive element counts while preserving accuracy. For interfaces, apply contact refinement so at least 1/2 to 1 element spans the gap. This improves load transfer. Then preview the mesh and inspect quality metrics like skewness and aspect ratio. If elements look poor, adjust local sizes and remesh until you finish by validating and exporting the mesh for analysis. Run a quick static or modal check to ensure the mesh responds smoothly. Look for hot spots or non-physical modes. Once validated, export in the solver format you need. Use MSH or CDB where supported. If something goes wrong, stop and isolate the offending region. Remesh locally with finer controls, remove highly distorted elements, or repair geometry. One key tip: always rerun quality checks after any fix to confirm the problem is resolved.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.